Now we've just built a pipe network, as you can see down here, that has one pipe above the ceiling, one pipe's going to be below the floor, and we've got another pipe here that's going to be for sampling the grill. Now what we want to do in these cases, we want to aggregate or sum up all the contributions of smoke through all the holes in the one pipe, and this allows us to have greater sensitivity in that room. So what we do for that is we go click on the detector and then click on this group details, and at the moment we have two groups, and we're going to create a third group and put each of the pipes in their own group. So to make it clearer, we'll just rename these. So if we go to this one here, we can rename that. We'll rename that the above ceiling. This one we'll rename to below floor. And this one we'll rename to grill. So we've got our three groups here, and we need to create this group, but we need to actually move these holes across. So we just click down here to reassign them. You'll notice as we did that the colours changed. If I just put one of these back here, you'll see that this one now has colours because it's the balance requirements aren't being met. The red indicates where the flow is too low or sensitivity is too high, and the other extreme is represented by this gold, which represents where we're actually getting really good flow and low sensitivity value. So as you can see, once we move these across, then we've actually ended up with something that's reasonable balance in both. Now one thing I wanted to point out to you here is if we aren't sure where one of these points is, we can click here and it'll highlight down our 3D view so we can see where each of these points are. Or alternatively, we can click on a point here and see it highlighted there. And one thing you do need to be aware of is the scroll bar for these points is actually right over here. So if you want to see, say in this case, the very top points, we have to scroll up here to get to those top points. Scroll down again to get to the bottom ones. But anyhow, what we want to do now is we want to optimize each of these different sorts of things they're measuring, and what we can do with that is we can define our own group types, and I've already defined some. So if we have a look here, there's a below floor, a default and a group, but it's nothing for above ceiling. So we'll implement the ones for the below floor and the grill. But if we're doing a lot of designs with above ceiling runs, then we'd be wise to define a type for that. So if we go up to tools, we have another category now, which is basically our group types. So here we can go and create a new one. Call this one ceiling, and we'll make these values just a moment. Now these values here are reasonably important. If this one is too low, you'll potentially get false alarms. If this one's too high, it means that it's not going to be, you're making it too tolerant to bad smoke conditions. So these need to be reasonable levels. So now we need to really click away from that and come back to it to reactivate that. So if we do that now, we can see we've got a ceiling option. We do that, and you'll see now that once we've defined a type, that these fields here are no longer editable. And in fact, there's one field here which is contribution ratio, and I just wanted to explain that one. Contribution ratio kicks in where you have a large room, and basically in a large room, if there was a fire incident, the fire would contribute to, unlikely to contribute 100% of the holes, because it would only get picked up by a certain proportion of the holes. And so if we know we've got a large room, this allows us to say, right, for this room, if there's a fire incident, we expect probably about half the holes will get picked up. So if I change that to 50, you'll see that it changes these values here and compensates for that in actual applied sensitivities. But I'll put it back to 80 because actually put it back to 100. Now you'll notice also that we didn't need to recalculate for any of this, because none of these values that we're changing here actually affect the pressures and the flows. We're just working with thresholds around those values. So by setting that all up, we can then check that the smoke that's aggregating through, I'll just widen this a little bit, but the smoke aggregation that's occurring in these groups is within the limits, and therefore we've got a design that's going to be able to, in this case, detect, for the first part up here, detect smoke collecting near the ceiling, for this pipe here be able to detect smoke from the floor, and this one would work for grills. So basically that's the sort of way that you can go about setting up your design. One other thing you can do at times, if transport times are getting really long, we don't have that problem here, but if we had really long pipe runs, we can actually use our end caps just to accelerate the flow and offer sensing smoke. And if we do that, then we can use this option here to use end caps to reduce transport time. And if we were to do that, then it creates another group where all the end caps essentially are being mapped off into this group here. So you can see that I've got that end cap there. This end cap here, etc., all been put off into this group, and this group is then used purely for accelerating the air through these pipes. And hence, if you look at the settings, it has a very large maximum target aggregate sensitivity setting. Anyhow, and of course we can always switch that back to creating a balanced design where all the holes, including end caps, count. When we do that, all end caps that were in that end group automatically drop back to the default group, so we'd have to reassign them back to these other groups. As like so. Anyhow, there is the way that we work with setting up groups.